Hey guys, what's up everyone? How are you people doing? Hoping that all of you guys are doing good and taking very good care of yourself. Welcome back to today's session. This is going to be for class 10th of CBSE, when we'll be talking about the magnetic effect of electric current. And my name is Anoop, and welcome back to today's session. So let us get started without wasting any more time. So the topic for today is that we're going to talk about is, guys, that is magnetic field and magnetic field lines. That's what we're going to talk about. One of the most two basic things that we have to understand in this particular chapter, so that we get a good grip on this particular chapter. Now, one thing, heads up guys, we have already seen this chapter. I don't know if you guys remember it. In your 6th grade you had a little bit of this, that is the understanding about the magnetic effect of electric current. Not too much of it, but you understood a little bit about magnetism and stuff. So you're probably seen about electromagnets and stuff in your 6th and 7th grade. This is going to be a much more advanced version of that, and that is pretty much it. It's not like a brand new chapter that you've never seen. That is what I want to tell you guys. Anyways, we'll start off the session also with a quote, as always guys. I don't think we are ever going to miss one. So here's the quote for today. Go confidently in the directions of your dreams, live the life you have imagined. And I don't think there is any more beautiful words than these put together in one single one single slide. I would say that yes, whatever is your path, whatever you feel is right for you, choose that. Don't believe all the naysayers. Make it come true. As simple as that. Alright guys, so I hope that all of you guys do make all your wishes come true. With that said, let us now get started with the topic for today. So we have 3 topics that will be covering in this particular chapter: magnetic field and magnetic field lines, which we'll be talking about today; magnetic field due to the current carrying conductors, which we'll be talking about in the next session; and then we'll also understand about force on current carrying conductor in a magnetic field. So these are the topics we will be covering as the days go by. So people, let us understand firstly what is an electromagnet before we get into understanding about magnetic field lines and magnetic field and everything. Let's understand about this. What is an electromagnet? In the most simplest terms, guys, an electromagnet is a magnet which behaves like a magnet unless and until the electric current is passing through it. So just because the electric current is passing through it, it behaves like a magnet, or it attains certain magnetic properties. That is what is called as an electromagnet. A type of magnet in which the magnetic field is produced only by the electric current. That is what is called as an electromagnet. One of the most simplest electromagnet is something that you see over here. So what you do is, basically, this is what is another version of a solenoid. Basically, it is nothing but a solenoid itself. So what you take a soft iron core, take a copper wire and wind it around it, and as soon as you connect it to a set of batteries, you can see that it'll start acting like a magnet. And why does it act like a magnet? Because of the current passing through the copper coil, there is a magnetic field created around it, and that is what allows it to attract all those paper pins as well. So that is what is an electromagnet. Now that you've understood this, let's understand about the person who we have to thank, or yeah, I don't know. Yes, we have to thank to basically who helped us understand about this, because there are a lot of applications here. No matter how much you scored in your mind, ultimately because of him there are a lot of things that is possible, including the fastest train in the world. It's because of him that it is possible right now. So it was Sir Hans Christian Ørsted who was the one who actually found the relationship between electric current and a magnetic field. Now this was actually an unusual discovery. It was not something that he planned on doing, nothing like that. So here's what happened. This is the story. So one day what happened, see, this was relatively new, all right? In the sense, electricity was a relatively new concept. This was around in the 1850s or something like that. So what happened was this, that he being a scientist, was working on a simple electric circuit. So what he did was that back in the day, obviously we did not have Google Maps, and also people used to carry a compass which tells them which direction they are going at. So what he did, he had a big table, so he placed this compass on the edge of the table, and he was working on his experiment. So he turned on the circuit and he was working on it. And suddenly what happened was that he started seeing that the compass started deflecting a little. Now at first he was scared, all right? At first, obviously, this was never seen before. Nobody had any clue about this. So he thought it was some ghost at first, frankly. Being a scientist, it sounds a little absurd, but then yes, at that point of time, it's a really viable option. So he thought it's a ghost, so he turned off the light, sat in a corner, and then, gathered up all his strength and turned it back on, and turns out that it again started deflecting. So that's when he, being a scientist, realized that it's not some ghost, but it has got something to do with the passage of the electric current in this particular circuit. So by that small accident, I would say, or that small mishap, the entire discovery of electromagnets and the relationship between electric current and magnetic field was actually discovered. So he understood that when there's an electric current or electric current passing through a circuit, there is some sort of magnetic field also produced around it, and that is what led to the deflection in that compass. Because in a compass, if you know the working of a compass, the reason why the compass is so effective is because the needle is actually magnetized. It's a magnetic needle, so it'll obviously that was the one thing that he understood, that yes, it's magnetic, so there should be some magnetic field around it, which is why it is getting deflected. And that's how the entire concept of this electromagnetism and the magnetic field lines and everything was actually created. Anyways, let's move ahead and understand a very simple experiment. Now, this is something that one of my teacher had shown me when I was in 10th grade. So this is what you do. You basically take a simple sheet of paper. You can take a paper, or here in this case they've taken a plastic sheet. So they took some iron filings. Like it's like powdered kind of iron. It is. It's not exactly like iron. What to say, the rod of iron. It's just iron filings you take, or you can call it as iron shavings. You take a simple bar magnet, keep it under the plastic, and just spread the the iron shavings around it. So what do you notice is this? In just a couple of seconds, you can see that all of those iron filings will start coming in a proper shape or a proper arrangement. Now this arrangement, if you look very, very carefully, you can see this. It actually looks like it is starting from a point and ending from it is starting from one end of the magnet and ending on the other end of the magnet. If you look at it very, very carefully. So this is what it actually looks like. The question is this: why do we have such grouping, and why are there gaps in between? Why couldn't be just one single, one single iron filings, like just like a big sheet of paper, like a big circle? Why not like that, and why like this? Now, what we're gonna understand is what is the reason for that. First of all, guys, that space that is there around that. So that magnet is creating a magnetic field around it. What do I mean by magnetic field? There is some sort of magnetic force of attraction that these iron filings are experiencing when they are near that particular magnet, and that is what is the magnetic field. So what is this magnetic field? The field, or that space around which where you can experience the magnetic effect, that is what is called as a magnetic field. Now you know that iron is a magnetic material. Iron, nickel, cobalt, all of these are magnetic materials, so which means that it would get attracted by a magnet, and this is what is happening over here. Now it's not like this magnetic field is like forever. For a certain magnet, there's a certain strength to the magnetic field, so it goes around to a certain distance. Even if you talk about the Earth itself, you guys know that Earth itself is a very big magnet, so it has a magnetic field around it. It does not go all the way out of the Milky Way galaxy or out of the Andromeda galaxy and all that. It just stays to a certain extent, and that field is what is called as the magnetic field, where you can actually experience the magnetic effect. Now, if you look at those, like I told you, it seems like they are starting from one of the edges of the magnet and ending on the other edge of the magnet. Now this, if you were to draw, if you were to connect these, the iron filings, the arrangement of the iron filings, you can see that you were able to draw some lines with some gaps in between. Those lines are the magnetic lines of force. Those are the magnetic lines of force. So basically, there's nothing but the lines which basically denotes the direction and as well as the arrangement of the magnetic field. So basically, it is the magnetic lines of field. Now, if you look at it very carefully, there are a few features, there are a few key features about these magnetic field and some of the properties, I might say, some of the properties that makes it so peculiar. The first property is that they are always going to be concentrated in places, or the number of lines will be more in places where the magnetic field is strong. Like in the case, if you look at it over here, see the North Pole and the South Pole, there are more number of lines, which means that the strength of the magnetic field over there is much more greater than that in the center. So that means that if the space between the lines is more, or if they're spread apart, then you can see that the magnetic field over there is weak. So from this case, you can clearly come to the conclusion that the magnetic field is going to be always stronger in the poles compared to that of the middle of the magnet. So it is always going to be very concentrated at the poles and very weak in the middle of the particular magnet. The third thing is this, guys: the magnetic field lines, it always starts or emerges from the North Pole and goes to the South Pole. It doesn't go from south to north, it always goes from north to south pole, outside the magnet. So outside the magnet, the magnetic field line starts from the north pole and it goes to the south pole. Now, why did I say this, sir? Why did I say this? That it's outside the magnet, because the fact is, guys, inside the magnet, the magnetic field lines are actually going from south to north. Inside the magnet, they're going from south to north, but outside the magnet, they're actually going from north to south pole of that particular magnet. That is something that you have to understand. There's a clear distinction between that. Inside the magnet, it is from south to north. It goes all the way from here to here. But outside the magnet, it's actually from north pole to the south pole. The last line does not make sense. It's outside the magnet. I'm really sorry about that, guys. So yes, that is what it actually looks like, and that is what it should be like. All right. So that is how it is, guys. One more thing about this is, guys, if you really want to find out the direction of the magnetic field lines, all you have to do is take any point of the magnet and just draw a tangent. If you join the tangent, or if you draw a tangent, you can find out the direction of the magnetic force. So whatever is the direction of the magnetic force, you can find it out by taking any point. If you draw a tangent to it. Now, what is a tangent? It's a straight line just touching the surface over here. So touching the circumference of that particular, field line. If you just draw that, you would be able to find out what is the direction of the particular magnetic field. Apart from that, guys, one question that I'm pretty sure that all of you guys had in mind, sir, what would happen if those two lines intersect? They're not trains. It can sometimes happen. They can come out of track and just meet. Now, what if that happens? Would there be like a nuclear holocaust? No. The fact is this, guys, it would never intersect. Now, why do I say it would never intersect, guys? See, if you take a compass, if you take a magnetic compass, the compass that shows the direction, if you bring it near a magnet, you could see that it'll start deflecting, which we have seen right now, that it'll start deflecting because of the magnetic field. There's some sort of deflection happening. Now, can a compass needle point at two different directions at the same time? Can it? Obviously not. It cannot point at two different directions at the same time, which means that a magnetic field line cannot have two different directions. It's physically impossible for it to have two different directions. So if you were to draw two tangents also, you see this one tangent is going this way, the other is going another way. So you cannot have, physically you cannot have two different tangents. And more importantly, even if you were to bring a magnetic compass, you cannot a magnetic compass cannot point at two different directions at the very same time. And because of this, guys, two magnetic field lines will never intersect each other. Never. And that, mark my words, guys, it's never going to happen. All right. So with that said, people, that is pretty much it. Now let's do some questions, understand whether we have understood the topic or not. Before that, guys, one more important thing I want to tell you guys is this, before we get into questions and question answers. Now, here's the thing. Right now, you guys already know that it's pandemic time, and I'm pretty sure that all of you guys are facing certain issues, right? Some of you guys might be finding it that you're not able to attend classes. Some of you guys might be feeling that sir, I'm not able to, clear my doubts. Some of you guys might feel that, sir, I'm not getting enough tests and assignments. Some of you guys might feel like, sir, I'm not getting notes. So these are some of the problems that we had asked you in the form of a survey, and these are the things that you're told. So the first problems that you guys face is doubts, sir. When do I clear my doubts? So I have certain websites which can clear the doubts, but they're tagged over there. The time for them to answer is somewhere between 24 hours to 48 hours. But I really don't want to wait for 28 to 48 hours for me to clear my one simple doubt, which just poses up when I'm reading a particular topic. So that is one of the problems. Second is not getting notes. Obviously that sir, I'm learning a lot of things from YouTube and other websites and stuff, but then I'm not getting the notes so that I can refer to it later on, or if I want to note down something, I'm not getting the notes. Although we try to do our best by putting down the notes in the description below, you can download it, but sometimes it's just not enough. It is about 90% of it, 95% of it is enough, but that rest 5 to 4% is still something that you have to fill up the gap for. Then tests and assignments, obviously, that you guys want to practice, you guys want more assignments, you guys want more tests to check where you're at before your board exams. You don't simply want to go and sit in front of your board exams and write whatever you know. That's not possible. Apart from that, you also want to prepare for competitive exams, right? Because yes, you all know the importance of having an Olympiad certificate, or you guys want to participate in a KVPY exams. So many things that you have, NTSE, KVPY, you have so many other aspirations to to conquer as the days go by. You also want a schedule of your choice, because sometimes you want to study at a particular time. Let's say that you want to study, you are someone who's more focused at 5 o'clock, but then the class starts at 7 o'clock and 9 o'clock, and it's something that you find it hard to cope up with. So you end up somehow sitting through the class and then doing nothing about it. So these are things I'm pretty sure that you can relate to all of these, and I'm pretty sure that you would have more than this also. These are some of the things that comes in your mind. Apart from that, yes, one of the most important thing, because of the whole reason why this channel itself was created, that is the choice of language. Whether you want to study in English, whether you want to study in Hindi, like maybe any other language of your choice. But then the problem is that we do not have that choice that we can choose whatever languages you want. But for now, the major if you talk about India, it's mainly divided into Hindi and then English. So that's how it goes. So how do we solve all these problems, right? That is the biggest question. So these are all the problems. So you told the problem. So what is the solution for it? So here's the thing, guys. Vedantu has solved all these problems, from doubts to your notes, to tests and assignments, to competitive exams, to schedule, and the choice of language. Doubts, whatever doubts you have a two-teacher model. You have a class teacher who will help you clear your doubts, and you have the master teacher to help you teach the topic as well as clear your doubts. So you have a two-teacher model, which means that you'll get personalized attention to make sure that all your doubts are cleared and answered. You have notes of every single session. So whatever the teacher writes on the whiteboard, you can download that and refer to it as many number of times that you want. You have tests and periodic tests and assignments to check where you are. And more importantly, is the best part about this test and assignments is that you would be getting a detailed report card of it, which would tell you where are the topics that you're going wrong, what are the things that you can do to make yourself better. And it's all artificial intelligence based, which means that everything, it's not like human interventions. It's machines learning what are the places that you're going wrong and what are the ways that you can make it better. Apart from that, you'll also have you'll be trained for competitive exams for free of cost. All your NSOs, your Olympiads, your NTSE, your Vedic math, whatever exam you want to try, we are there to help you out. Apart from that, you can choose the schedule of your choice. It's not like you have to come when the teacher wants. Whenever you feel like studying, you can choose that particular time and study in that particular time. And the choice of language, you can choose whichever language you're comfortable in. Either you want to study in English or you want to study in Hindi. It's totally up to you guys. All right. Now, apart from these guys, apart from these things that I just told you, you'll also have so many other bonuses, starting from unlimited live classes. That means if you want to study 10 hours a day, you want to attend 10 classes, live classes, go ahead, do it. If you want to attend 24 classes a day, go ahead, do it. Nobody's going to stop you. As long as you have enough data in your geo pack, as long as you're ready to sit and burn your eyes, you can do it. But it's a choice. You have all micro courses and crash courses for free. So if in case you want to study a particular chapter, you can choose that and study that alone. Performance report card, which I just told you, you'll be getting a detailed performance report card at the end of every month, depending on what tests and assignments you take. And you'll get personalized attention. Like I told you, you'll have a class teacher, and you'll also have someone called as a personal teacher to help you guys clear your doubts and make sure that you're going in the right track. All right, people. Now, here's the thing, guys. All you have to do is visit this website, that is vdnt.in/ytpro, and make sure that the YT Pro is in capital and all the others are in small. And don't forget to put the black backslash as well. You will be, as soon as you enter this website, you would get something like this where you have to choose the grade. So Vedantu is catering from 1st to 12th grade. So basically, we're covering all our bases. Soon we'll be covering for other grades as well. For now, it's from 1 to 12. So let's say that you're a person who's studying in 10th grade. So you chose 10th grade. And we also have syllabuses. You can choose 3 different syllabuses. You have CBSE, ICSE, as well as Maharashtra board. We'll be adding more to it, but for now, this is how it is: CBSE, ICSE, and Maharashtra. So let's say that you're in CBSE class 10th. So as soon as you click on it, this is what you're going to get. So you will get all these, whatever I just told you, everything: unlimited live classes, access, interact with India's best teachers, which I totally believe, and unlimited in-class doubt solving, test series assignments, guaranteed score improvement, and choice of your own schedule. So just all you have to do is basically get subscription. If you click on that, it'll take you to this website. Now here is where the magic starts. So here's the thing, guys. For 1 month subscription, before any kind of discount and anything, the cost of that is 2,699 rupees. For 3 months, it's roughly about how much is around if you think about it, per month, it's around 1,961 rupees. So what I'm trying to say is this: without discount, your 1 month subscription cost is 2,698 rupees. If you use the coupon code AKPRO, you'll get the price down to 2,294 rupees. For 3 month subscription, let's say that you want to choose for that. Again, monthly price would come down. So it'll come down to around 2,300 rupees per month. And your amount that you're going to pay is 6,999 rupees. But if you use the coupon code AKPRO, you will get the price down to 5,949 rupees, which is essentially you'll be getting a discount of 1,000 rupees. Now, if you let's say that you want to go for the 6 month subscription, then the price comes down from 11,499 rupees to about 9,778 rupees, essentially giving you a discount of 1,700 rupees, roughly about 2,000 rupees. Now, here's the thing, guys. What we're gonna do is we're gonna do a little math just to understand what exactly are we looking at. So here's the thing, guys. Your subscription price for 1 month, 2 month, and 6 month, without any kind of discount, this is what it is. So 2,699 rupees, 8,097 rupees, and 16,194 rupees before any kind of discount. After basically the basic discount or the primary discount itself would get the price down from 8,000 rupees to 6,999 rupees, and for 6 months, it'll go from 16,000 rupees to 11,502 rupees, which means that you're getting a discount of 4,000 rupees. With this, if you use the AKPRO discount code, you will get the price down to 2,219 rupees for the 1 month subscription, and 5,949 rupees for the 3 month subscription, and 9,774 rupees for the 6 month subscription. Now, here's the thing, guys. Let's say this. Let's take a simple math. All right? I might go wrong in calculation, so here and there. So do correct me. Let's say that you are taking 6 subjects. All right. So we are covering all the 6 subjects, from your science, your maths, social science to English, and all the other subjects. So let's say that you're taking 8 classes in a day. All right. You can have how many ever you want. For example, let's say that you're taking 8 classes in a day. So in 4 weeks, how many classes you're taking? Sorry, in 7 days. In 1 week time, how many classes? In the sense, 7 days, you're taking about 50 classes. So Sunday is a holiday, so ignore that. In 6 days, you're doing about 50 classes, 48 classes to be precise. But let's say that for calculation matter, to make it more easier, let's take it 50 classes, because obviously I just told you, me and math, we are not good friends. So 50 classes. Now, let's say that you're taking the whole month subscription, that is for 1 month, that is 4 weeks. So into 4 is about 200 classes, roughly, again, 4 classes. Obviously, 200 classes, like that's itself, like, aur kitna padhoge, exactly, how much more will you study 200 classes in a month? Now, if you just calculate, that is for the first month, 2,294 rupees is what you're going to pay after the discount. And if you're doing 200 classes a day, let's calculate how much. And if you're doing for 3 months, that's about 600 classes, because obviously 200 into 3. And for the 6 months course, it'll be 200 into 6. So that's about 1,200 classes per, in total. So the cost of it, we have just seen right now. If you calculate it, you will get the price as 11.47 rupees for 1 class. If you're taking the 1 month subscription. For 2 month subscription, you're getting the price down to 9 rupees 19 paise. For 3 month subscription, you're going to get as 8 rupees 145 paise. Now guys, if you just look at the price, this is definitely lesser than the price that you pay for lace, which is apparently 20 rupees and 80% air. So yeah, that's how it is, guys. You can do the math. All you have to do is visit this website and enter the coupon code. Do not forget the coupon code AKPRO. That is it, guys. That's all the math I had to do. With that said, let us now get back into the questions and try to solve some questions. All right. I hope you guys checked it out. You're going to check it out. Here's the first question. The space around the magnet where the magnetic effect is felt is what? Magnetic field lines, magnetic field, iron filings, or magnet. Now, I want all of you guys to put down the answers in the comment section below. I want everyone to give your best. Don't just expect me to give the answer. I want you guys to try it out. So here's the question. The space around the magnet where the magnetic field is felt is actually, the answer is option number B, which is the magnetic field. So that is the place, like I told you, the area around which you're, like, if you talk about gravitation also, there's a certain extent, or there's a certain distance from the Earth's surface where you can actually feel the gravitation. So in the same way here also, if you talk about magnetism, there's a certain distance around which you can feel the magnetism. That is called as the magnetic field. Second question, guys. Inside the magnet, the magnetic field lines move from north to south, south to north, away from the south pole, or away from the north pole. Inside the magnet, what is the direction of the magnetic field lines? And the answer, guys, is option number B again. Sorry. No, this should be wrong. Is inside the magnet, the magnetic field lines move from south to north, not from north to south. Apparently, the answer is wrong. The answer is actually option number B. Inside the magnetic field lines move from south to north, not from north to south. Alright, this is outside the magnet. If the question was outside the magnet, the field lines move from north to south pole, but inside the magnet it moves from south to north pole. Right? It's a very simple typo error. It's alright. Next question. Right, which of the following statement is not correct about the magnetic field? Magnetic field lines form a continuous closed curve. Magnetic field lines do not intersect each other. Direction of tangent at any point on the magnetic field line curves gives the direction of the magnetic field at that point. Outside the magnetic field lines go from south to north pole of the magnet. The question is this, guys: which statement among the four is not true or is incorrect about the magnetic field lines? The first option, magnetic field lines form a continuous closed curve. Magnetic field lines do not intersect each other. Direction of tangent at any point of the magnetic field lines curve gives the direction of the magnetic field at any point. And outside the magnetic field lines go from south to north pole of the magnet. And the answer, guys, is very straightforward. It's option number D, because yes, outside the magnet, I just told you it'll go from north to south pole, not from south to north pole. Inside the magnet, however, it goes from south to north, but outside the magnet, it's from north to south pole. All the other statements are correct. The last one is the one which is false. Last question is, the second last question: by which instrument the presence of magnetic field be determined? Galvanometer, magnetic needle, ammeter, or a voltmeter? And the answer, you guys already know for it, a magnetic needle. It's very simple. So if you bring a magnetic needle near it, if you see some kind of deflection on it, then you can clearly see that there is a magnetic field present around that particular object. So as simple as that, guys. You just have to bring the magnetic needle close to it. As simple as that. Last question, people. Here we go. A magnetic field line will be crowded at location where more iron fillings are. The question is, a magnetic field line will be crowded at location where more iron fillings are attracted. Magnetic field is strong near the poles, or all of the above. It's a very interesting question. I'm pretty sure that many of you guys might go a little wrong in this question. However, let me tell you the answer. The answer to this question is all of the above. Because yes, if there are more iron filings, then obviously that means that the magnetic field over there is stronger. And yes, that again, the option number 2 is exactly that. Magnetic field is strong. So if the magnetic field is strong, the more number of iron filings will be collected over there. And thirdly, exactly like I told you, in a bar magnet, you have the poles where the magnetic field is strong. So it'll be option number C as well. So the right answer is all of the above, guys. That is it. So with that said, people, here is your homework for today. Again, I want you guys to let me know in the comment section below what the answer for this question is. The question is, who discovered the magnetic effective current? Very simple question. Let me know what is the answer in the comment section below. Thank you for joining, people. I hope you enjoyed today's session. Thank you once again. Thanks a ton for all your support and love. If you did like today's session, leave a like and subscribe to the channel. Thank you for joining. See you all in the next one. Take care of yourselves. Stay safe. Bye, people. Take care.